All right, so today we're going to cover 1.5, Solving Inequalities Day 2. Hopefully by then today you'll be able to solve multi-step inequalities. Now before that, let's do a little bit of review about what inequalities are and if inequalities are true. So looking at number 1 right over here, I noticed that I have an inequality that says the left side is greater than or equal to the right side. Now it is my job to find out if this is true. So let's kind of treat this as two sides of an equation, except that this time it's an inequality. And let's figure out what all this stuff equals. Now, using my rules of PEMDAS, I know that there are no work to be done in the parentheses, no exponents. I'm going to start with multiplication. So 5 times 3 is 15, plus 2 better be greater than 12. Now it is my job to figure out what 15 plus 2 is. 15 plus 2 is 17. Now, is this a true inequality? Does it hold true? Is 17 greater than or equal to 12? Yes, so that means that this inequality is true. Let's go to the next one. Now, 99% of students want to distribute within the parentheses, but keep in mind, we're not technically solving for anything. We're just seeing if the left side is less than the right side. So let's use our rules, our order of operations, to figure out if this is true. So notice that there is some work to be done within the parentheses this time. We need to figure out what 5 plus 8 is. 5 plus 8 is a positive 13, which is less than 1, or is supposed to be less than 1. Now I notice that I have a negative 2 times 13. So that means I'm going to multiply those to equal a negative 26, which should be less than 1. Or is it less than 1? Is negative 26 less than 1? Yes, so that means that this is a true statement. Keep in mind that sometimes these are not going to be true, so that means that you have a false statement. All right, so let's do a little bit more work. Now notice that there was no variables and there was nothing to substitute, but now they are asking us in this situation here, is x plus 12 less than 7? Now, when they're asking us if when x is equal to a negative 5, is this inequality true? So what we got to do is we got to take that x equals negative 5, plug it into our x, and do exactly what we did all here on these problems. So let's plug in the negative 5. Negative 5 for my x, I just substituted it. Plus 12 better be greater than 7. Now negative 5 plus 12 I know is 7. Now is this a true statement? Is 7 greater than 7? No, so this is a false statement. That means that negative 5 is not a solution to this equation. Let's try another. So number 2. Notice I have x divided by 5 plus 1 is less than 1. So let's start with plugging it in. Negative 5 divided by 5 plus 1 to check to see if it's less than 1. Now solving the division first, negative 5 divided by 5 is a negative 1. I'm going to add 1 to see if that's less than 1. Now negative 1 plus 1 is 0. Now is 0 less than 1? Yes, this is true. So that means that this is a true statement. Now this is kind of just a really quick run of what inequalities are in terms of their solutions, of proving one side might be bigger than the other, or hold the inequality true, seeing if a solution is true to a specific inequality. Now what we're going to start doing is solving pretty much equations with inequalities, but there is one property that you have to look for when dealing with inequalities. Now, just to give you guys a little background of where they come from, let's start with an inequality that I'm making up that I know is true. Let's say that 2 is less than 3. So whenever you have inequalities, what I mean by properties of inequalities is that you could add or subtract to the left side and the right side. As long as you add or subtract the same amount, your inequality is going to hold true. So that means if I add 5 to this side and I add 5 to the other side, if I treat this like an equation, what I do to one part of the inequality, I do to the other, my inequalities are going to remain true. Notice that 2 plus 5 is 7, 3 plus 5 is 8, 7 is still less than 8. Notice that you could also subtract. Let's say I subtract 1 on both sides. I end up with 6 on this side, I end up with 7. My inequality still remains the same, so nothing changes. You can add and subtract to two sides of an inequality and nothing happens. You're going to be okay. Now notice that that is not true when you're multiplying. Let's start with something that is simple, something like 2 is less than 3, the same thing. But now let's multiply on both sides. So I'm going to multiply this side by 2, this side by 2. Notice I end up with 4 is less than 6. My inequality still holds true. Nothing changed. But look what happens when I multiply by a negative. I'm going to change colors so that way you see it. Let's multiply by a negative 2 and multiply this side by negative 2. If I multiply these, I end up with negative 8. If I multiply this side, I end up with a negative 12. Now remember your number line. What is bigger, a negative 8 or a negative 12? The negative 8 is, right? It's kind of like owing less money. I like to think of negatives as money. So if I owe $8 and owe 12 and someone else owes 12, I'm technically the richer man, if that's what you consider rich. So notice that whenever you multiply by a negative, you have to flip your inequality, because what it really does is it makes big numbers smaller with the number line. All you have to worry about is like, okay, I multiplied by negative, or I multiplied by negative, I'm going to flip my inequality. And same is true with division. Just to make sure you got it, let's start with 6 is greater than, let's do 4. That is a 4, by the way. If you divide by negative 2 on both sides, notice you end up with 6 divided by negative 2, which is negative 3. 4 divided by negative 2 is a negative 2. Again, what is bigger in this situation? The negative 2. So notice again, when you divide or multiply by negative, flip that inequality. If you don't, you will get the wrong answer. So don't freak out about that. That was just really quick. This is the program that I'm writing to make sure I'm able to write. So let's start solving some equations. And keeping in mind that whenever I divide or multiply by negative, I'm going to flip that inequality. All right, so let's give it some time. There we go, we're good. So let's solve for this inequality here. I want to know for what values of n, so anything I plug in makes this inequality true. So in order to solve these are solved exactly like solving equations. The first thing you're going to do when you see parentheses like in this one is you're going to distribute that negative 2. You end up with 3 minus 2n plus 8 is greater than a negative 1. After that, I could see that there are two sides of inequality. I'm going to start combining like terms. Here's a 3, here's a positive 8. I'm going to add those, and I end up with a positive 11, and that is still greater than negative 1, because remember, I haven't divided or multiplied by negative. Minusing 11 on both sides, I end up with, I'm going to write a little more space over here, I end up with a negative 2n is greater than a negative 12. Finally, dividing by negative 2, n is greater than 6. Now, you guys might have seen like, oh man, he made a mistake, but I remembered last minute that whenever I divide or multiply by negative, I have to flip the inequality. So do not forget, or unfortunately you're going to get it wrong. So this is my solution. If I tell you to respond in inequality format, that is exactly what you write down. If I tell you to graph, you have to graph. And most of these I am going to tell you to graph. So remember how to graph. You put your 0 in front. Notice that 6 is somewhere out here to the right. Now this is going to be a closed dot or open dot. It's going to be open because there is no line underneath my inequality. Now when are my variables less than 6? They're less than 6 in this direction. So any number you choose in this direction, 5, 4, 3, anywhere over here, you're going to get an answer. Let's make sure to put this in neural notation. I notice that my answers pretty much go all the way to negative infinity, all the way to a 6. Both are going to be parentheses because I'm not including them. So that is pretty much the basis of how to solve these. If you know how to solve equations, you know how to solve inequalities with that little bit of remembering when I multiply or divide by negative, I'm going to flip the inequality each and every single time. So keep that in mind. So number one, I notice that I have variables on both sides, but more importantly, I have an annoying fraction. So let me get rid of that fraction to begin with. I'm going to multiply by 9 on this side, multiply by 9 on this side. These cancel out. You're left with a negative 9m is less than or equal to m plus 4. So this got a lot easier very quickly. All I'm going to do is minus m on this side. These are going to cancel out. For a little more space, I'm going to write over here. End up with a negative 10m is less than or equal to a positive 4. Notice that I did not divide or multiply by negative, so I'm still okay. Dividing by negative 10 on both sides, end up with m is less than or equal to a negative 2/5, because again, all I did there was divide the top and the bottom by 2. I reduced there. All right, so almost done. I noticed that I need to put this, I need to graph it, so here's my 0. Notice that negative 2/5 is somewhere over here. This one's going to be a closed dot because I have my less than or equal to. Now, when are my variables less than? They're less than to the right. So that means that if I were doing my interval notation, it goes from negative infinity all the way to a negative 2/5. Now, keep in mind that this is a closed circle, so I'm going to leave a bracket at that negative 2/5. All right, next problem, I'm going to do this one in that kind of purple color, so that way it's a little easier to see. Let's start with distributing. You end up with 6q minus 12 is less than 6. Now I can see clearly that I only have one q, so I'm just going to solve for that q. End up with 6q is greater than positive 18. Dividing by 6 on both sides, I end up with q is greater than 3. So luckily for us, we didn't have to do any flipping or anything like that. We didn't have to deal with dividing and multiplying by negatives. This will be an open circle. Notice that my q's are greater, so that means it's going to go to the right. So where are my intervals? Where are my answers? If I was to put this in interval notation, where do I start from? So notice I start from 3 and I go all the way to infinity, to positive infinity. So that means I'm going to go from 3 all the way to positive infinity. This is an open circle, so it's going to be a parenthesis. And of course, infinities always have a parenthesis because you can't technically be exact. All right, last but not least, let's solve for this one right over here. Remember, the first thing I recommend is always distributing. You end up with a negative 2b minus 2 plus 4 is less than 10. Now, let's combine my terms. So I have a negative 2 and a plus 6. So that means that negative 2b plus 2 is less than 10. That's minus 2 on both sides. You end up with a squiggly, JK. You end up with negative 2b is less than a positive 8. And then finally, dividing by negative 2 on both sides, you end up with b is less than negative 4. Hopefully you guys thought you were going to get some extra credit, because remember that whenever I have something wrong and you find a mistake, which happens more often than not, let me know when you turn in your assignment. I'll give you full points. What I was trying to get there is that look what I forgot to do. I divided by a negative. When you divide by negative, what happens to your inequality? It flips to the other side. Now let me double check. I'm not trying to give out too much extra credit. Yep, I wrote my inequality correct. It was just a less than, which turned it into a greater than. So that's my answer. But let's finish it out. We have the 0 right in the middle of our number line, negative 4 somewhere over here. This is going to be an open dot. Now my b's are greater, so it's going to go in the greater than direction. So if I were to put this in interval notation, from where to where are my answers? Now my least value is negative 4, so they go to negative 4 all the way to positive infinity. Both of these are going to be parentheses because they're not included. So again, if you see a mistake, let me know in your when you turn in your assignment, and I will throw in some extra credit. Why not? Mistakes are okay. They happen. So make sure that if you catch mine, you let me know so that way you can get some extra credit.